Everybody, just wanted to take some time to go over question 4.51 from Brown, LeMay, Burston. And so feel free to follow along. Feel free to try the questions yourself, whatever you want, and let's have at it. Okay, so let's look at question A. It says, which of the following is oxidized and which of the following is reduced? Okay, so this is rules of the rules of determining what the oxidation states are. So remember, for elements, the oxidation states are 0. Okay, and then for the compounds, the oxidation states, hydrogen is typically 1+. Okay, and so there's a whole list of rules about hydrogen and whatever, and so there's 3 of those. So if hydrogen is 1+ and there's 3 of them, that means that the nitrogen must be 3-. So because of that, hydrogen is gaining charge, so it's losing electrons. So hydrogen is the oxidizing, and nitrogen is the reducing, is being reduced. Okay, now let's take a look at this. Now, experience tells me that it's going to be aluminum and iron here. Okay, only because I have nitrate here and I have nitrate on this side. Nitrate's not changing at all. It's just going to be a spectator ion for the reaction. Okay, but here we go. We have aluminum, or might as well. I'll stick with aluminum. So you have aluminum here at 0, okay, and iron here is 0. So what happens to iron between here and here? Well, iron, remember, nitrate has a 1- charge. There's 2 of them, so iron is a 2+. So iron is going from 2+ to 0. So iron is being reduced here. Okay. So iron is being reduced. And so that means that aluminum is what's being oxidized. But to complete it, let's just see. So again, nitrate is minus. So that's 3-. So this is 3+. I'm going from 0 to 3+, definitely being oxidized. Okay, so let's take a look at chlorine. Chlorine here, that's a 0 because it's an element. Here, iodine is an element. Okay, keep Hankelbrief in mind. Hydrogen, oxygen, nitrogen, chlorine, bromine, iodine, and fluorine. Those are all the ones that have. Those are all the elements that are diatomic, are found in nature as 2 elements. Okay, and so here's sodium. So this is I. 1-, so 1- to 0, and this is sodium chloride going to 1-. So if we look at what's happening, we're seeing chlorine is losing electrons, it's reducing. Okay, I'm sorry, it's gaining electrons. I always get that screwed up. It's being reduced because the charge is going from 0 to -1. The only way for that to happen is for the chlorine to gain electrons, right? Electrons are negative, we're gaining a negative charge. Go from there. Okay, and so by process of elimination, that means iodine must be oxidized. Okay, but let's do that for completeness. We're going from 1- to 0. Okay, that's right. It has to be losing electrons. Its charge is going up. Okay, so here's lead and lead. Okay, so this one's a little trickier because it doesn't have any. You would imagine that the metals are typically what we've been dealing with that will be oxidized and reduced, but here lead is a 2+ because sulfur is 2-, but here lead is a 2+. So that because sulfate SO4 2-. Okay, so it looks like we're going to have to go in through here and figure out what the heck is going on. Okay, so let's let's do that. So let's look at sulfate, and then we'll look at the oxygens and the hydrogens. Okay, sulfate, SO4 2 minus, that's a polyatomic ion. The charge on oxygen, the oxidation state of oxygen, is always 2 minus. There are 4 of them, so that's a total of 8 minus. We need the overall charge to add up to 2 minus, so that means sulfur must be a 6 plus. So sulfur is going from a 2 plus, 2 minus to a 6 plus here. So that charge is going up. So sulfur is what is being oxidized. Okay. Now let's look at hydrogen. That's the next one here. Hydrogen in this case. Hydrogen has a +1 charge because this is the peroxide polyatomic ion. The peroxide polyatomic ion, which is this, has a 2 minus charge. So this is 2 plus. And now here, this oxygen has a 2 minus charge, and this is 1 plus. So hydrogen isn't doing anything. So the only thing that can be happening here is oxygen has to be doing something. So let me get out the red pen because there's a lot of markings here. So peroxide, as my voice cracks, peroxide, O2 2 minus, that means that each oxygen is a 1 minus. Here it's 2 minus. So here oxygen is, its charge is going down, so oxygen is the thing that's being reduced. Okay, so knowing your oxidation states help out here a lot, okay, or your rules for oxidation states. So that's 4.51, and have a great day.